Hello, hello. I am giving this whole live stream thing a try, and so I thought I'd just basically sit here and do some problems, some completing the square problems, and that is because that's what we're doing in the class that I teach, so I thought it was a good place to start. I'm not going to promise that I really know what I'm doing as far as live streaming, but I'm giving it a try, so let's not be too mean about it. Let's see how it goes. Okay, so first problem, let's see if I've got this set up well. Completing the square is one of the ways that we solve quadratic equations. And so a quadratic equation is something that has a squared term, and let me see if I can start off with something that would be super easy, that it would not be easiest for us to complete the square on this problem, but oh, that's not a good one. Nope, I see that would be a problem. That number right there. That's the thing, is there's a lot of ways to solve quadratic equations, and so it's not actually the best way to do it most of the time. Usually any other way works. For instance, we could factor this if we know how to factor. We could graph this and we'd be able to find the answers pretty easily because of what they are, and we could solve this with the quadratic formula. I would argue that it is probably easier to complete the square on this particular equation than to use the quadratic formula, but it's not always the case. So it's important that you understand, yes, there's multiple ways that we could solve this, and completing the square is not the best option. The reason that we learn how to do it in this context is there's a couple of reasons actually. One is that this actually allows us to see how the quadratic formula was derived, or how we can come up with a quadratic formula ourselves. We can do it with completing the square. And the other thing is we do use completing the square other places than this, and this gives us a really good way to practice. And so an easier way to practice, you could say, actually. So the steps for completing the square is we are going to complete the square on our x terms. And so I'm going to start off by rewriting this so that the 12 is on the other side. And I'm going to leave a spot here because that's where I'm going to complete the square. What my goal is I'm going to put a number here so that I can end up factoring this into two parentheses that are the same. Now, since I'm going to have to put something here, I'm going to add or subtract something. I'm also going to put a blank on the other side because what I do on one side, I'm definitely going to need to do to the other as well. So what I want to do is I want to think about what number should I put here so that I could factor this into two parentheses that have the same number. And at first, that's not necessarily an easy thing to even wrap your head around. But think, since we're talking about factoring, it's a number that's going to multiply to get this right here, and it's a number that adds to get this right here. And so in light of that, we need the same number twice that adds to get 8. The numbers that work for that are 4 and 4. So we're trying to factor this into x plus 4 times x plus 4. And in order to be able to do that, we need to have what number in this blank, what multiplies whenever I do 4 times 4. So we need a 16, and we need to add it to both sides. Now that's kind of a long explanation of why or how we do that. I guess that's the why it's 16 that we put there and what our goal was. But there's a really easy way to remember how to get this number 16. You take the number in front of x here, you half it, and you square it. And I have a memory tool for that, where we talk about Professor Hoffen squared. I can't remember if there's two F's in professor or not. Professor Hoffen square is a German professor who really did a lot of good work with completing the square, and it's important to remember his work because he's the one that teaches us to take this 8, half it, and square it. And so, since he's German, perhaps this is kind of, I don't know if this is like a dig at Germany or not, but because he's German, you half it, like the accent is I'm really saying half. So we're going to half the 8 and then square it, and that's how we get the 16. So you take the 8, you half it, so divide by 2, you square it, and that's how we get 16. And so all of this was just to figure out what to put in this blank. And so now we're going to move on. We actually don't have to write this step. We can go straight to writing this as x plus 4 once with the squared on the outside. That was the whole purpose of us doing that, because now if I do negative 12 plus 16 and get 4, now I can say, well, everything on the left here is squared, so I can get rid of that squared by square rooting both sides of my equation. And so that means I have x plus 4 equals, the square root of 4 is 2, but since I square rooted in this equation, I need to put a plus and minus sign so that I will get the 2 answers that the fundamental theorem of algebra suggested at the beginning that I should. Because it's a squared equation, we should have 2 answers. But we have to remember at what point to put that plus and minus. And that point is, if you square root, you need a plus or minus. Then I'm going to subtract 4 from both sides. And so x equals negative 4 plus and minus 2, which I can actually find those 2 answers. Negative 4 plus 2 is negative 2, and negative 4 minus 2 is negative 6. And like I said at the beginning, we could have come up with that pretty quickly probably if we've done any sort of factoring recently in our lives. We have said, oh, to multiply to get 12, add to get 8, we need to do 6 and 2. And then we put it in parentheses and then subtract those numbers over and make them negative. And so if something is factorable, it's definitely easier to factor instead. Let's look at one that is harder than that doesn't give us such nice answers. So I've got a variety of problems here that I'm going to pull from so that I know already that they work out in some way how I want them to. And one thing is this is kind of from an Algebra 2-ish or maybe even pre-calculus standpoint, and so there will be imaginary numbers that appear here, or there's a possibility. They won't all be imaginary, but they could be. So we want to complete the square on this, and so our first step is to rewrite it as n squared minus 6n and put a blank here and move the 71 over so that it says minus 71. And then we want to say what needs to go in this blank to complete the square. And so we need to half the negative 6, and then we need to square it. And it's important that you remember that saying you're going to square a number and that number is negative, you need to make that negative go away. Negative 3 times negative 3 is positive 9. And because of that, this number we put here in this blank should always end up being positive. And I'm going to put positive 9 on the other side as well to keep my equation balanced. So the next step is to say, okay, what's the number that you multiply together to get 9 and add together to get negative 6? So that number always happens to be this in-between number I got whenever I halved and before I squared. So I'm going to put a minus 3 here. And then negative 71 plus 9 is negative 62. I'm hoping not to embarrass myself with math errors, but it happens. That's life. So we'll see what happens. And at this point is where I can square root both sides so that I get n minus 3 equals positive and negative. Now the only thing I can do with this is get the negative on the outside and write it as an I, and then on the inside I'm going to leave the 62. Now 62 is 2 and 31. neither of those are perfect squares, so I can't simplify it. I'm going to leave it as the square root of 62. Oh, I was about to box it, but I'm not done yet because I need to add 3 to both sides. So n equals 3 plus or minus I square roots of 62. And so this is a problem that we would have had to resort to the quadratic formula. That's the alternative to solving with completing the square. And so I have actually had some students say that they like completing the square better. And it really, in my opinion, depends on whether or not there are fractions when you start completing the square. So we'll see a couple problems like that here in a second. Before we get there, we need to address one other thing. I need to make this do a problem. Well, that's gross for its own reasons, but we'll go with it. Okay, so this is going to be an added step that we need to think about on here, because we want to do, let's see, this is 3x squared plus 6x plus 94 equals 0. If everything here was divisible by 3, that would absolutely be the best way to go, but that 94 is not divisible by 3, so we can't do that, or at least we can't do that yet. We still want to move the 94 over like we've been doing, but then the way I've typically seen this done is you factor the 3 out like this, and because we're factoring it out, we don't need to do anything on the right side. Now, you could actually at this point divide the 3 over. If I don't divide the 3 over right now, then it delays where I get a fraction in the problem, which might be a good thing. Maybe I don't really like having fractions. So, but it is going to add a complication to us that is a key area that students tend to mess up. So we want to half and square 2, so we want to half 2 and get 1, and then we want to square 1 and get 1. So I'm going to put plus 1 right here. But here's the thing, I didn't really add 1 on the left side of this, I actually added 3. If we think about, if I distributed the 3 back through, what number is really in this spot? It's 3 times 1, which is 3. That's what we're going to add to this side. And like I said, that's an easy place to mess up in this problem, is to forget to do that. So we want to not forget to do that. Now that 3 is going to stay there until we're ready for it. We're going to factor this, so the number we got when we halved was 1, and then negative 94 plus 3 is negative 91. Now I'm going to divide by that 3. We need to divide by it before we square root, otherwise we'll have to square root it as well, which we're going to have to square root it anyway, so I guess this is just a making it look nicer sort of thing. And so that we don't just forget about the 3. So now I want to square root both sides. So I get x plus 1 equals, don't forget your plus or minus. We're going to pull out the negative and make it an I, and then 91 is not divisible by 3. So what we have is the square root of 91, and in fact 91 is 7 times 13, which doesn't simplify at all, much less with 3. Now, when you're in the situation where you've got a square root on the bottom of your fraction, we are supposed to rationalize that. We're supposed to get the square root off the bottom of the fraction, and we do that by timesing by what that square root is. So I need to do 91 times 3, which is 273. It changes my square root on top, and on bottom it cancels out the square root. Square root of 3 times square root of 3 is square root of 9, which is regular 3. So now this looks unfortunately as pretty as I can get it, and now I want to finish by subtracting 1 from both sides and get x equals. I personally like to put the number negative 1 first and then the plus or minus. It kind of makes it seem like our like the answers we get when we do the quadratic formula, that good old friend of ours, the quadratic formula. And so here is one version of our answer. The other version of our answer is to actually get a common denominator here to put these together in a fraction. And I would argue that it's not worth the extra effort to do this. You'd basically have to make this be -3 over 3. And so that's how we get -3 plus or minus I square roots of 273 over 3, which I did not actually have enough room for you to see. So let me rewrite it up here. Didn't know that was going to be an issue. We're just making it to where it's all over 3. Kind of like, you know, the all over 2a of the quadratic formula. So that's if we have a coefficient, what we're going to do. And now let's talk about how this can get really, really frustrating really fast. Let me pick out a good one here. Also, they don't have to give it to us so nicely where everything is on the correct side to start. Like, we could have something like this, and we know that we need to move the -7b over to the left so that the v's are together. And then we need our spot here, but the -64 could stay over there. That would be fine. And then we're going to put something right there as well. Now and this may look like it's better than the last one because there's no coefficient, but what do you get when you half 7? You get 7/2. And then what do you get when you square 7/2? Well, you square the top, square the bottom, and get 49 over 4. So that's what I'm going to put here is plus 49 over 4, and that's what I'm going to put here. And chances are your teacher would prefer that you work with fractions instead of decimals, because if we start using decimals, we're going to end up rounding and possibly create a rounding error. And we just really like it when you know how to use fractions, just by the way sort of situation. And so we could at this point change it to a mixed number, but we're just going to have to change it back to work with it. We could change it to a decimal, but again, like once we get to the square root of whatever it is, we want to be able to simplify that square root if possible. So my basic gist of that is leave it as a fraction. Okay, so here's where our trick comes in of this middle number always being what goes in the next step, because when I half 7, I get 7/2, and otherwise that number might be hard to come up with. Oh, I want to get -64 plus 49 over 4, 64 times 4, I actually do know this off of my head, I just forgot for a second, is 256, and so instead of -64, we're going to be doing -256 over 4 plus 49. Oh boy. So 207, -207 over 4. So see, this just got a lot worse. Really, 49 over 4 wasn't a terrible number in the broad scheme of things if you're a math person, but there's just something uncomfortable about -207 over 4. Although that is divisible by 3, but I don't think that's going to help us. Alright, let's square root. V plus 7/2 equals positive and negative. We know we've got an I. Hey, we know the square root of 4 is 2, so that's nice because that means that we don't need a square root on the bottom anymore. 207, I said it was divisible by 3. 3 goes into 26 times with 2 left over. 3 goes into 27 9 times. And 69 is also divisible by 3, and that's 23. So we can simplify this into 3 square roots of 23. So I'm going to put the 3 in front of the I and leave the 23 on the inside. And that's that simplified. Now I can just subtract the 7/2 over to the other side. So -7/2 plus and minus 3i square roots of 23 over 2. Or in this case, since they're already both over 2, it really makes quite a bit of sense to just go ahead and write them as one fraction instead of leaving them separate. Like, it's my personal opinion that maybe it's not worth the rewrite, but, you know, to each their own. You can make that decision, I suppose, yourself. Alright, so our next one that we're going to do is going to combine the two unpleasant things of before that we're going to have to factor out, and we're going to still end up with trying to half a fraction. And so the point to doing all this is to explore what happens with fractions, to remind ourselves what we need to be doing whenever we encounter these fractions, but also another good reason to go through this is it would help us think through deriving the quadratic formula, which if I have time here, I'll go ahead and have us do that real quick, because it is kind of fun. This needs to be a -88. I decided to move it over to save myself some writing, and then I didn't save myself any writing because I just had to do it anyway. Had to erase it. Okay, now this is gonna get crazy, math crazy. We need to factor out this coefficient 8. And so to factor out an 8 from 17, which doesn't have an 8, we divide by it. So if you think about the process by which we factor a 2 out of 6, we divide the 6 by 2, right? So I'm trying to factor an 8 out of 17, and I can't, so I just set that up as division. That's the start of our problems here. And then I now need to complete the square on 17/8, so I need to half 17/8, so times by half, and get 17 over 16, and then I need to square it. Question is, do I happen to have these numbers memorized? I know the top one's 289. Hello, Joe Don in the chat. I am getting closer to 1K subs, and I am pretty excited about it. That's part of the reason for doing the stream. 256 is 16 squared. Shout out to Joe Don, who helped me acquire my intro for my YouTube videos. Thanks a bunch. I think it's been a huge hit. Alright, anyway, so we halved the 17/8 and got 17 over 16. We're squaring that, so we've got to square the top and the bottom. So what I'm going to put right here is 289 over 256, which, let's face it, can't be much more terrible than that. Then, to put it on the other side, I actually need to think, what is 8 times that? That's what's going to go on the right side. So 8 times. Now, typically by Algebra 2, you're allowed to use at least a scientific calculator, and so be sure to utilize that. Like, I could just, if I had my scientific calculator handy, I could type this in, and somewhere there should be a button on your scientific calculator that lets you change decimals to fractions, so that if you're like, oh, I can't, it doesn't help me if I need it to be a fraction. Well, somewhere on there is a button that will help you. You just got to find it for your particular calculator. On the TI graphing calculators, if you press math, enter, enter, it changes it for you. Alright, so this is what I get when I times by 8. It actually helps make the denominator smaller, which I feel like is a good thing. So this is what we're adding, is 289 over 32. I am using a calculator to do some of this math. I'm just using my phone calculator. Okay, next step. 8 is still there. We want to write this factored, and so we need to use our in-between number here, the 17 over 16. And now I need to do negative 88 plus 289 over 32. So what is 88 times 32, so I can get a common denominator? It is 2,816. And so I need to do 2,816 minus 289, and my answer should be negative, so negative 2,527 over 32. This is definitely the point where it's like, well, I'm crossing my fingers that I haven't messed this up. Yeah, I'm not super confident about that. Let's just keep going. If you've noticed a mistake and want to shout it out to me, in text form in the chat. That'd be super helpful. We're going to divide by 8. So n plus 17 over 16 squared equals, we're still negative. When you divide by a number, that's the same as multiplying by the reciprocal. And so the important thing here to think about is when you divide a fraction by a number, it affects the bottom number. 32 times 8. I feel like we undid that earlier, so that's going to bring us back to 256, which really makes me think, by the way, here that there's something about this that I'm actually doing more work than I need to. Haven't actually sat around doing enough completing the square to figure out exactly where that is, but I think it's happening somewhere. Pretty confident about that. Alright, n plus 17 over 16 equals positive and negative. We're going to pull that negative out and make it an I. The 256, the square root of 256 is 16, so that's cool. How about this 2527? I happen to know what the answer is, which means that I know this does simplify. The question is, what does it simplify by? So I know that 7 goes into it because I've seen the answer, and so if I didn't know that, it's a good thing to try with such a large number. Now that gives me 7 times 361, and this is just going to get better because I'm pretty sure that's divisible by 19. It is. 361 is actually 19 squared. And so that means that I can write this as 19 square roots of 7. Take a look at that beautiful number. And then I subtract 17 over 16 from both sides. Now, I'm a math teacher, not a person who particularly enjoys torturing my students, so this is probably a little more difficult than what I would give them maybe on an assessment, but I do think that there is a little bit of merit to walking through this at least once, even on your own, just so you can be like, bam, like drop my pencil, I did that, you know, that's an achievement, like we just completed the square. This is not some rookie business that anybody can do. Like, there are people who like would rather do, like, pay you money probably than have to do this problem. Actually, most people probably would. Feel free to pay me money. So wait, never mind, forget I said that. Okay, the point of this was, like, especially having to know what 361, or not 361, 2527, especially having to simplify that, that's a bit much. You'd have to guess and check, and so 7 wouldn't be hard to come up with necessarily, but knowing that 361 is divisible by 19, a little bit of a stretch. I know some of us have squares memorized, but not all of us. So if you're like, oh man, is this a teacher who puts this kind of question on a quiz or a test, expects everybody to be able to do it? No, I'm going to go with one at least a little bit easier than this. Probably a lot easier than this. But you've seen it. You can now take this and apply it to deriving the quadratic formula. And that's where I'm going to end this, is we're going to derive the quadratic formula together. You're going to see the magic happen. So the quadratic formula works for ax squared plus bx plus c. And so in order for us to figure it out using completing the square, we need to start off with just a, b, and c instead of numbers. And so that's going to make this a little tricky. If you thought the fractions were hard to work with, this is maybe going to blow your mind. So our first step, just like before, and if you happen to have been like writing these down, you have notes to look at. Our first step, like before, is to move the number that doesn't have a variable over to the other side. And then we want to factor out our coefficient a. And so just like on this past couple problems, when we factor out a from this, which is not actually divisible by a, we have to write it as a division problem, like so. And so what we're going to do is we're going to need to half and square b over a. we just did that sort of thing with some fractions that weren't too nice. So I would argue this is even worse. We're going to half it and get b over 2a. That's kind of a thing that's familiar to me from, the quadratic formula. Now we want to do b squared, and then we want to also square the 2 and the a, so that's 4a squared. Now that's less familiar, but that's what's going in this blank, b squared over 4a squared. But in this blank, we need to put what happens when we distribute the a. So we got to use our exponent rules here, that a times b squared over 4a squared cancels an a out, so that on this side I'm adding b squared over 4a. Now we're going to factor, so that a is still hanging out, and then we want to factor this, so we're going to use this middle thing right here, so x plus b over 2a squared equals, and then we're going to do, let's see, negative c plus b squared over 4a. We need a handy dandy common denominator here, and so the common denominator is going to be 4a, and so to get this to have 4a on bottom, we need to multiply the top by 4a as well. No, there's something else that looks familiar. Now that we have common denominators, we're going to put these 4a's together as one denominator and put all this on top. And I'm going to switch it around. B squared minus 4ac all over 4a. Wait, I don't know about that. All over 4a. That's not how the song goes. Alright, let's divide this by a on both sides. Hello, Caleb. Whoever you are, thanks for watching. Here we go, squared. Now when I divide by a, that's like timesing by 1 over a, and so that's going to put another a on bottom, so that we end up being 4a squared. And again, like the top is looking pretty good here, but the bottom is like, that's not quite familiar. So our next step is to square root, and this is where the end of our magic kind of happens. I guess it's the second to last piece of our magic. We've now got rid of the squared. We're going to put a plus or minus, and we're going to break this up because we can't actually square root b squared minus 4ac. And hopefully you realize that, if nothing else, because that's a really big part of the quadratic formula. Clearly, if we could square root it, we would have after all this time. But it's because of the subtraction that you can't like take the b squared out of the square root. You can't take the 4 out. If this was multiplication all the way through, then yes, we could, but it's not. On the bottom though, 4a squared is in fact 2a, which again looks familiar. Finally, subtract b over 2a from both sides. Let's put that in front, and let's write this all over 2a perhaps, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, let's say you want to impress your friends with your completing the square skills and you don't want to have to memorize a quadratic formula. Ta-da, here's your option. But if you are looking to memorize the quadratic formula, you can put it to the tune of Pop Goes the Weasel. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Or, I've actually been working on trying to put it to, I would say Twinkle Twinkle Little Star, but really it's more of an alphabet song vibe, so I'm not sure that live stream is the best place to debut this, because then it'll be there for forever. But let me think. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now I know the quadratic formula. Next time, won't you sing with me? I think it needs some work. But in case you're not a fan of Pop Goes the Weasel, I think the alphabet song works pretty well as well. So that's where I'm going to end this stream. I hope you have enjoyed completing the square, or if you watch this later, hope you get something out of it, because basically that's about as easy as we can get with completing the square, all the way to as hard as we can get without any numbers whatsoever, and everything in between. So feel free to subscribe to my channel if you aren't already, and I will see you guys on the flip side.